So today we're going to be working on Eureka, Module 5, Lesson 15. So let's go ahead and get started. Our objective today is we're going to use math drawings to represent subtraction with up to 2 decompositions, relate drawings to the algorithm, and use addition to explain why the subtraction method works. So what you notice is that this is the same objective from the last 2 lessons. So we're going to be drawing place value chips, we're going to be using the algorithm, and we're also going to check our work with addition. Okay, so things to remember. Remember the difference is the answer to a subtraction problem. 10 is the same as 10 ones. 10 tens is the same as 100. Materials for today. You'll need a place value mat, that's optional, and a whiteboard marker. So let's go ahead and get started. We're going to start with our application problem today. The application problem says Catriona earned 16 more stickers than Peter. She earned 35 stickers. How many stickers did Peter earn? Well, let's talk about what we know. We know that Catriona earned 35 stickers, but we don't know how many Peter has. What we do know is the difference. We know that she had 16 more. So remember, what we can do is we can do 35 take away 16 is equal to the amount of stickers that Peter has. Or we can also write the problem this way with the missing add-in. We could start with the number of stickers Peter has and then try to get to 35. So we try to find the missing add-in. So one way we can do that is by using the arrow way. So we can start at 16, and then to get to a friendly number, I'm just going to jump 4, and I'm going to get to 20. And then I'm going to jump 10 because that'll take me to 30. And then if I jump 5 more, I get to 35. So now if we add all of our jumps together, we have 10 plus 5, which is 15, and then 4 more is 19. So we can go ahead and put the answers in right there, and we can say Peter has 19 stickers. Okay, there's a part A. It says Mary Jo earned 47 stickers. How many more does Peter need to have the same amount as Mary Jo? Well, we know that Mary Jo has 47. And we know that Peter has 19 stickers now. So now we have to find the difference. So to find the difference, I can write a number sentence just like that, because when we have the whole and we have one part, we can just subtract that part and we always find the other part. So we have 47 take away 19, or again, we can write the sentence like this where we try to find the missing add-in. So we know that Peter has 19, and then we don't know the difference, but we do know that we want to get to 47. So if I make an arrow way, I could start at 19, and then I want to make that a nice, juicy, friendly number. So that's going to, so jumping 1 will jump me to, so if I jump 1, I'll get to 20. And then if I jump 20 more, that'll take me to 40. And then I just need to get to 47. So if I add 7, I get to 47. So if I add those up, 20 plus 7 is 27, and 1 more is 28. So I could say Peter needs 28 more stickers to get to Mary Jo's stickers. Okay, now that we're all warmed up, let's go ahead and get started on our concept today. I have 430 take away 129. Now I'm looking at this problem, and normally we write it in vertical form, and then what we do is we put it on the place value mat, but I'm thinking about something. This looks like a problem I can solve in my head. And the reason why I can solve it in my head is because look at those hundreds right there. What if I do 400 take away 100? That equals 300. And then what if I look at those numbers, 30 and 29? I can make a problem with 30 take away 29. That's equal to 1. And so 300 plus 1 is equal to 301. So remember, if there's problems that you can just solve in your head, and you can use mental math, use that mental math. You don't always have to line a problem up. These are just those types of problems that you can leave in horizontal form, and it makes it nice and easy to subtract without having to do all of the other things. So if mental math is one of those things that you can do it. Okay, let's look at this problem. 560 take away 258. Again, I'm thinking, so I'm looking at that 58 right there, and 58 is pretty close to 60. So I can do this the same way I did the other one, like 500 take away 200 and then 60 take away 58. Or I can also do 258, and then I can make that 260, And then I can just jump to 560 right there. So if I put those numbers together with the arrow away, that leads me to 302, and that is the answer. So this is called the arrow away method, but you're still using your mental math skills. Okay, now you can see I have my place value chart ready to go. Today we're not going to be working with chips, we're actually going to be working with dots because on your independent work today you will be drawing things out. So let's look at 941 take away 587. I'm going to write that in vertical form, and let's go ahead and represent our numbers. I have 900, 4 tens, and 1 1. Okay, so let's look at the numbers in our ones place. I have a 1 and I need to take away 7. I cannot take away 7 from 1. So what do I have to do? More on the floor, then go next door and get 10 more. So now I have 10 more. Let's see what that looks like on the algorithm. I no longer have 4 tens, I have 3 tens, and now I don't have 1 1, I have 11 ones. If you count those all up, that's 11. Now do I have more on the top? More on the top, no need to stop. Let's subtract 7, and that leaves me with 4 ones. So let's go ahead and move on to our tens. I have 3 tens and I need to take away 8. Well, I can't do that without getting some from my hundreds. So more on the floor, then go next door and get 10 more. And there's my 10 tens. So let's go ahead and see what that looks like on the algorithm. I no longer have 900s, I have 800s. I no longer have 3 tens, I have 13 tens now. More on the top, no need to stop. Let's subtract 8. And I'm left with 5 tens. And then I'm ready to move on to my hundreds. I have 8 and I subtract 5. So there goes 5 hundreds and I'm left with 3 hundreds. So my answer is 354. So let's go ahead and look at my number bond. My whole was 941, my part was 587, and the other part was 354. So if I check my work, I'm going to go ahead and put those numbers in the number bond. Let's line up our parts. 587 plus 354, and 7 plus 4 is 11. Put your tens up high and your ones down low. Let's add 8 plus 5. 8 plus 5 is 13. One more is 14. So remember, put your tens up high and your ones down low. 5 plus 3 is 8, and one more is 9. So it's like a fact family. All those numbers work together, and we know that we subtracted correctly because our parts are equal to the whole. Okay, let's go ahead and do another one. I have 624 take away 225. So here is my vertical algorithm, and let's go ahead and represent this number on the place value chart. I have 6 hundreds, 2 tens, and 4 ones. Remember, when we have our number bond, we have our whole and our part. So let's go ahead and look at our ones. I have 4 ones, but I need to take away 5. It's possible, but I have to do some work. So more on the floor, then go next door and get 10 more. So let's see what that looks like on the algorithm. Instead of 2 tens, I have 1 10 left. And instead of 4 ones, I have 14 ones. So 14 take away 5 is 9 ones. Okay, now let's look at our tens. I have 1 10 and I want to take away 2. I have more on the floor, so we're going to go next door and we're going to get 10 more. And now on the algorithm, I no longer have 600s, I have 5. I no longer have 1 10, I have 11 tens, and now we're ready to subtract 2. So there they go, and now I'm left with 9 tens. So if I put that in the algorithm, it lines up nice and straight, and we're ready to go to the hundreds. I have 5 hundreds and I need to take away 2. No need to unbundle anything, I just take away 2, and I'm left with 3 hundreds. So my answer is 399. And if I put that in my number bond, it looks just like that. So let's go ahead and check our work. There's my algorithm, and here's my number bond again, whole, part, parts. So let's line up our parts, 225, 399, and let's see if we subtracted correctly. 5 plus 9 is equal to 14. Put your tens up high and your ones down low. I have 2 plus 9 and 1 more. Well, I know that 9 plus 1 is 10 and 2 more is 12. So put your 10s up high and your 1s down low. And then I have 2 plus 3 and 1 more, and that's 6. So again, we have our perfect fact family and all of our numbers work together beautifully because we did our work correctly. And that's it. So I hope you learned something new, and let's go ahead and show you what your problems are on Seesaw today. Okay, so this is the first problem in your problem set, 800 take away 675. So you can go ahead and draw your diagram right here. I've lined it up vertically for you here, and then you send it on over and you check your answer. And your second problem is 742 take away 495. So let's go ahead and see your work, and we'll talk to you later. Bye.